Hey, hi everyone. Lesson 2.5, multiplying a polynomial by a monomial. So by the end of the lesson, you should be able to multiply this polynomial by a monomial and simplify your expression. So to be able to do that, we're going to have to look at what's called the distributive property. So if we take a look, we're going to use a little example to help us figure this out. So we have a rectangle that has an unknown length and a width of 4 units. If the length is increased by 7 units to create a larger rectangle, we want to write a simplified algebraic expression for the area of the new larger rectangle. So if we take a look at this one, right, we've got this original rectangle over here, right, its width we don't know, and then we want to increase it by these 7 units. So the width of the new rectangle, right, we have the x, and then we're adding 7 more units to it. The length of our new rectangle, well, they didn't say anything about changing that, so in this case it would just stay 4. And then the area of the new rectangle, well, normally area is length times the width, so the length was 4, and the width is 4 times x plus 7, okay? So we're going to look at how do we do this, right? How could we simplify that further? That's going to be known as our distributive property. We also call it expanding. So in our distributive property, we're going to have something like a and then a bracket, and then we're going to have some type of polynomial inside the bracket. To distribute, we're going to take whatever is out in front of the bracket and we're going to multiply it by each term inside the bracket. So it would become a times b plus a times c. So this is our distributive property, just the general form for it. Okay? So we're going to try some of these so we can get the hang of it. So in this case, we have 3 and then times g plus 4. So we have to multiply everything in the brackets by 3. So 3 times g is just 3g plus 3 times 4, well, that's 12. And then that would be it. We can't simplify that any farther because there's no like terms. If we try this next one, right, again, the negative 7 gets multiplied by everything inside the brackets. So negative 7 times q is just negative 7q. And then negative 7 times positive 3 is negative 21. If we just have a minus sign, it's like saying negative 1. So we're going to multiply everything in the brackets by negative 1. So negative 1 times 2t is just negative 2t, and negative 1 times negative 1 is positive 1. And then this last one here, we've got a negative 4 times a negative w. Well, negative times negative is a positive 4w. Negative 4 times negative 5, positive 20. So now we can also try this with a variable. It's a little bit different. Our rule is still the same, so we're going to multiply everything in the brackets here by x, but now we have to think of our exponent rules. So if we had x times 2x, well, our exponent rules tell us if the bases are the same that we're going to just add the exponents. So we've got 2x and a 1 plus a 1 is squared. Plus, and then x times 5, just 5x. Okay, so we're going to try a couple more of these with the variable out in front. So again, multiply everything in the brackets. So b times b is just b squared, plus 1 times b is just b. So we can also have numbers and variables. So again, we just follow our similar rules. So 3p times p, well, the 3 doesn't change. P times p is just p squared. 3p times 4, 3 times 4 is 12, and keep our p. So again, negative r times negative 5r, well, a negative times a negative is a positive, so that'll give us a positive 5. R times r squared. Now here, negative r times 2, so a negative times a positive is a negative, and then 2 times r is just 2r. And this last one, so we've got a negative 3w times a 2w, so negative 3 times 2 is negative 6, w times w is w squared. Negative 3w times negative 1, negative times a negative is a positive, 3 times 1 is 3, and then we keep the w. Alright, so now we're going to try and expand or use the distributive property with a coefficient and a variable. So we kind of saw some of those, but this time we're going to have different exponents on our variables. So same rules apply. We're still using our multiplying powers rule. So in this case, we would take 3x times 9x squared. So 3 times 9 is 27. X, right, our bases are the same, so we add our exponents. So we've got 1 plus 2 is 3. Next, we have 3x times negative 4x. So 3 times negative 4 is negative 12. X times x is x squared. Okay. So let's try a few more of these with some even bigger exponents. Alright, so we've got 3y times negative 4y to the 6. So 3 times negative 4 is negative 12. Our base is y. y1 plus y6, y7. Next we've got 3y times 2y to the power of 3. So 3 times 2 is 6. Y, and then this is a 1 and a 3, so 1 plus 3 is 4. Right here, we don't have any like terms because this has an exponent of 7, this has an exponent of 4, so we're done. So next we can try 5z squared times 3z, so 5 times 3 is 15, and then z, well, 2 plus 1, if we use our exponent rules, is 3. So then 5z squared times negative 1, so 5 times negative 1 is negative 5, and then we just keep our z squared. Okay, so now we have a trinomial, so we have to do this 3 times. So negative 2x to the power of 4 times x squared. So negative 2, again, there's nothing here, so it's just a 1. So negative 2 times 1 is 1. X, 4 plus 2 is 6. Next term, negative 2x to the power of 4 times negative 3x. So negative times a negative is a positive. 2 times 3 is 6. And then we've got x, and now we have 4 plus a 1 is 5. Last term, negative 2x to the power of 4 times 9. So negative 2 times 9 is negative 18. And then x to the power of 4. Alright, last one. So it doesn't matter which way these are written. We can distribute like we have been here forward, or we can distribute backwards as well. It works the same way. So in this case, make sure you still write it in the order it was written in this first polynomial here. So I'd say 11a times a is 11a squared. And then 11a times negative 1 is negative 11a. Okay, so now we're going to try combining everything we know about simplifying expressions. So that means everything from yesterday plus everything from today. So we want to distribute first, and we can do 2 sets of brackets at the same time. So here we've got 2b squared, then 2 times negative 4b is negative 8b, and 2 times 3 is 6. Okay. And then in this one, 5b plus or times b is positive 5b squared, and then 5b times 4 is plus 20b. Now we collect our like terms. So we have a 2b squared plus a 5b squared. We've got an 8b or negative 8b plus 20b, and then we've got a 6. plus 6. So then, right, 2b squared plus 5b squared is 7b squared. Negative 8b plus 20b is plus 12b, and then we just have this plus 6 on the end. Okay. Alright, so we've got a couple examples to try, and then that's the end of this lesson. Okay, so let's try these 4. So distribute first. So we're going to have a negative 3p plus 6, negative times negative positive, and then distribute over here, so plus 6p, and then plus 6. Then we collect our like terms, right? So we got our p's, and then we've got our constants. So negative 3p plus 6 is just 3p, 6 plus 6 is 12. Okay, so distribute to everything in your brackets here. So a times ab squared. So a squared b squared, right? Exponent rules. A times negative 4b, negative 4ab. Remember to write in alphabetical order. And then a times 3 is just 3a. Next set. 2b times a squared b, so we've got plus 2a squared b squared. And then 2b times a plus 2ab, alphabetical order. And then 2b times 4 plus 8b. Alright, so now we want to write this out in order here, collect our like terms. So I would say, okay, so I would do my a squared, b squareds first because they have higher exponents. Then I would do my ab's, then a's, then b's. Alright, so here we've got 3a squared b squared. Then we've got minus 2ab plus 3a plus 8b. Okay, last two. So again, now we have to think of our bedmass as well. So order of operations still counts here. So we want to do our inner brackets first. So leave this 3. And then here we want to distribute. So negative 2 times 6, negative 12. Negative 2 times negative t is positive 2t plus 5t. I'm going to simplify inside my brackets first. So I've got a 2t and a 5t, that makes a 7t. Then I'm going to distribute here. So 3 times negative 12 is negative 36, and 3 times 7 is 21t. And then we should rewrite this with the proper order. Alright, last one. So distributing here all the way across first. So negative 5m times m, negative 5m squared, negative 5m times 5 is, negative 25m. Alright, next set of brackets, so we've got negative 2 times 3m squared is negative 6m squared, negative 2 times negative 4m is positive 8m, and negative 2 times negative 7 is positive 14. Alright, so then we can collect our like terms, so we've got m squareds are first, then m's, and then our constants. Okay, so then our m squareds, we've got negative 5 minus 6 is negative 11. Our m's, negative 25 plus 8 is negative 17m. And then we've got this plus 14 on the end. Okay. Alright, so that's the end of that lesson. Make sure that you try your homework and check